Very good morning. Today we are going to discuss about the content microprogrammed control under the paper of control logic design. Here we need to know about what is microprogrammed control. Here the control unit with its binary control value stored as words in memory is called microprogrammed control. Here in this each unit consists of each word in that control memory contains some micro instructions that specifies one or more micro operations for a given particular system. This sequence of a process of micro instruction constitutes a micro program. So this is called the microprogrammed control. Next, we are going to see microprogrammed control unit. Here there are 5 parameters are given below: control word, microroutine, microinstructions, and control store. So first one is control word. What is control word? It is a word whose individual bits represents various control signals in the microroutine. Some bit represents the various control signals. It's called control word. Number 2, microroutine. What is microroutine? A sequence of control words corresponding to the control sequence of a machine. Instruction constitutes the microroutine. Here the correspondence the control sequence and a machine instructions, then it is called microroutine. Number 3, micro instructions. A single instructions in a microcode is called micro instructions. It differs within a same computer family and even the same vendor. So within this platform we can able to shift the instructions in a microcode. Next, control store. What is control store? It is a part of central processing unit controlled unit device that it stores the central processing unit micro program. So these are all the 4 parameters coming under the microprogrammed control unit. Next, what is micro instructions? Here micro instructions is a most elementary instruction in the computer, such as moving the contents of a register to ALU. What is ALU? Arithmetic logic unit. It takes several micro instructions to carry out one CISC. What is CISC? Abbreviated by complex machine instruction cycle. It is called micro instructions. Then microprogrammed control unit can be classified into 2 types based on the type of control word stored in a control memory. Here there will be different types of micro instructions depending on the encoding of control signals. Number 1, horizontal micro instructions and vertical micro instructions. First one we are going to see about horizontal micro instructions. In that horizontal micro instructions, the control signals are represent in the decoded binary format, that is 1 bit per control store or control SIR. Here n CS required n bit encoding, so CS is a control store. So within that situation we need to handle or we need to direct the micro operation or each control signal. CS is a control signal or control store. Here some of the general attributes are given below. What is that? Long micro instruction word and parallelism in the high degree of freedom and encoding in a control information. Next, this is a schematic sketch of the horizontal micro instruction flow diagrams. Here there should be a internal CPU control signals and the other end is system bus control signals. In between micro instruction branch addresses. With the help of that we can develop some supports longer control word and allows a higher degree of freedom, that is parallelism. Here no additional hardware is required for the state and it makes less usage of ROM encoding. These are the parameters are given below. And then horizontal micro instructions are giving a flow chart. First of all, executing the instructions through the input and then turn all the control lines. Without control lines we can't do anything with the bit value equal to 1. So we are giving a number of values, it should be compensated to the bit value up to or equal to 1. Here there is two conditions, one is false condition, another one is true condition. If it going under the statement of false, the execution should be repeating the format of sequences. If it is true, the next micro instructions should be executed is indicated in the next field. So we can be stored in a following manner. Next one, vertical micro instructions. What is vertical micro instructions? The control signals are represented in the encoded binary format. Here in control signals requires log base to n bit encoding. Here some of the micro instructions word are given below to express the parallel micro operations and encoding the control informations. Next slide. These are all the vertical micro instructions parallelism flow diagram. Here it supports shorter control word and it allows low degree of freedom of parallelism, and it should be 0 or 1. That is a major feature of the given series. We can generate a control signals, then only we can give a situation to the decoding following principles. Here we need to require to generate a control signals with the source of decoding section. Without decoding section we can't able to generate a control signals. In between there is some branch addresses. Next one, it make use of read-only memory encoding condition is more to reduce the length of the control word. Here we can't do anything, but the 32 ALU operations only 5 encoding bits will be required for the vertical micro instructions. Already we have discussed in the flow diagram. We need to generate a control signals. With the control signals we need to get the decoding sections, then only we can implement this control signals. Next one, basic organization of microprogrammed control unit. Here the sequence logic unit issues reading command. At the same time, word specified in a control register is read into control buffer register. Here what is control buffer register? It is based on the contents generate the control signals and next address information. Here we need to introduce some sequence logic loads or reads new addresses into control buffer register based on next address information from control buffer register to accumulator or ALU flags. Here these are the key elements are discussed below: control memory, control address register, control buffer register, reading instructions and sequencing a unit. Next one, functioning of microprogrammed control unit. What is the microprogram control unit functions? Here this figure shows a control memory and the associated hardware needed for selecting the next micro instruction addresses. Here there is schematic sketch. In between the control memory, before CAR, that is control address register, and the bottom is the control buffer register. With that processor we can able to do some future success. Here each micro instructions in control memory contains a set of bits to initiate micro operations in computer registers. A set of bits that specify the method by which the next micro instructions address is obtained. This diagram shows you some different paths from CAR control address register receives the address of the next instructions. This is the major function of microprogram control unit, and some of the control unit executions functions are as follows. Here there should be a reading command and the word should be phrases into the control address register and conformed into the control buffer register, and The control buffer register generates signals to the next sequencing logic addresses, and then the same sequencing logic unit loads to the ALU flags. Everything should be happened during the one clock pulse. Without clock pulse, we couldn't move from one place to another place. Next one, microprogrammed control unit advantages and disadvantages. Here there are some few points to be discussed for the advantages session. It simplifies the design of control unit, and it should be very less prone of to implement, and it is very cheaper, and the functions are implemented in software rather than the hardware. It should be more flexible and reliable to accommodate the new system specifications via laptop, iPhone or mobiles and Android versions, and situation depends upon your users. And then last one is debugging and maintenance of the microprogrammed CPU is easy. And some disadvantages are mentioned here, that is slower than the hardware, and then flexibility is achieved by some extra hardware cost due to some memory and access circuitry. The last one is the design duration is more than the hardware control unit because the CPU is smaller than the mentioning unit. The next is micro instruction sequencing. Before that, we need to know about the hardwired and microprogrammed control comparison. Here some of the attributes are mentioned below. There are 10 attributes, I think so: speed, cost, implementation approach, flexibility, complex instruction ability, design process, sequencing logics, some of the major application regarding syscan risk, and memory of control, and a chip area. So from that attribute we can able to differentiate hardware and microprogrammed control unit for your references. Next is microinstruction sequencing. Here, what is microinstruction sequencing? Here, to get a microinstruction from the main memory, the sequencer is the most important window to learn how to use in MediaWorks author. Here, sequencer is the key to the successful projects in present and future. So here there are two microprogrammed control unit sequences are microinstruction sequencing and microinstruction execution. First of all, we are going to see microinstruction sequencing. Here, what is microinstruction sequencing? Some of the design considerations are mentioned below. Size of the microinstructions. Here it includes the size should be decreaser, the cost will be very cheap. And address generation time. In address generation time, the instruction register once per cycle after instruction is to be fetched. Next, the sequential adder performance. In that sequential adder performance, common is most designed and designated, and then branches. In that branches there are two configurations, one is conditional, another one is unconditional. These are the design considerations to implement a micro instruction sequencing. Next, micro instruction sequencing, some implementation techniques are to be discussed. Here there are three general categories to be framed for the information of format, that is two address fields, single address fields, variable address format. Here first of all we are going to see the two address fields. This is a schematic sketch you are going to be seeing. Here what is two address fields? A simplest approach is to be provide two address field in each micro instructions, and multiplier is provided to select address from the second address field. Starting address, that is starting address means we are going to be started from one place to another place. So it is a starting address, is based on opcode field in the current instructions. This is called two address fields. The schematic sketch is very similar to each other for the two address fields and a single address field and the variable address field. Next we are going to see single address field. What is single address field? Here two address approaches is simple, but it requires more bits in the micro instructions with a simpler approaches. Here we can give single address field in the form of micro instructions with the following options. Why we are going for the options? Because to next address, the address field is based on the opcode in the instruction register. This is called single instruction field. Next is variable format. Here one bit designates which format is being used. We need to identify which format is we are going to be used. In first format, remaining bits are used to activate control signal. In second format, some bit drives the branch logic design or modules, and the remaining is to provide the address register. These are the differences between the two address field, single address field, and the variable format. And the last is micro instruction execution. Already we have seen micro instruction can be divided into divided into two categories. One is sequencing, another one is execution. First of all, you have seen micro sequencing and then three formats, and then last is micro instruction execution. Here the execution is includes the sequencer for controlling the sequential readout of micro instructions from a read-only memory for storage in micro instruction register and for subsequent decoding by a decoder, because the cycle is every event of the basic situation. Each cycle is made up of only two events. You may also know one is fetch, because without fetch we can't able to do the process, and is execute. Execute is a execute the full operation given by the input session. Here that determines the generation of instruction and as well as the addresses, and then it should generate a control signals and the control points internal to the processor, because from the memory we can able to access the processing input sessions, and then rest to go the external control bus or other interface. Without control bus we can't do anything. Okay, let me go for the summary. Here we are going to see the microprogrammed control unit. From the control unit we need to know what is microprogrammed control unit. In that there is some 4 parameters. You may also know some parameters need to be discussed, and then major two things is one is sequencing, another one is execution. In that sequencing there are three variable formats, and then last one is micro instruction execution. So let me discuss the remaining sessions later. Thank you.